দেখেন চুপ। স্যার আপনি সামনে এসে বসেন। রাদি আর ইসাম এই লাস্ট বেঞ্চে বসো। এইটা
It's harder to hear the Doppler effect at 440 hertz rather than the car horn. Can we just stick with the car horn?
Okay, we can go back to the car horn. However, the Doppler effect is easier to understand if we refer to a single frequency. So let's keep referring to the demonstration as a single frequency, but use the car horn demonstration. Sorry, Bobby. We're back to you. You are telling us what this animation of a stationary sound source actually represents.
Right. Remember, sound is a longitudinal pressure wave.
And those lines are crests,
which are also called wave fronts.
Yeah, thanks. So sound is periodic changes in pressure in the medium, which in this case is air. Each of those lines represents a crest in the longitudinal pressure wave. That means each crest or wavefront is a location of high pressure. That periodic pressure wave transfers sound energy through the air. And the reason all those circles are the same distance from one another is because the sound source is oscillating in simple harmonic motion at a constant frequency.
And do not forget that each circle actually represents a spherical pressure wave or wavefront going out in all directions from the sound source. It is a circle instead of a sphere here because this is a two-dimensional space. Very nice, everybody. Now remember, this animation is for a stationary sound source. Look at how the animation changes when the source of the sound is moving. Make sure you are aware that each of those circles, which are actually spheres, represent the sound coming from where the sound source was when it emitted the sound. To make that clear, I have highlighted one of the wave crests so you can see that it is a sphere that is increasing in size, and the center of that sphere continues to be in the location where the power was when the sound was emitted by the speaker's output. Sometimes that is a concept which gets lost in the overall understanding. Okay. Now let's add a human to our animation. Notice the human, or the observer, is currently located such that the car, the source of the sound, is coming towards the observer. So, what do you notice about the distance between the spheres that are going towards the observer?
On the side of the car where the guy is, the circles are closer to one another.
And what does that mean?
Well, the circles represent crests in the wave. And the distance between two crests of a wave is the wave.
Okay. This is the video from Flipping Physics. It's an amazing physics channel. You should look it up. This teacher is amazing, like really amazing, super good. I want you to understand what is being shown here. Let's try to understand the key concept that is happening. Whenever the source of sound, in this case the vehicle, is in relative motion with respect to the observer, which is the person standing on the left, I hope they don't hit each other. So let's not get there. Okay, so what is happening that if the sound source was perfectly stationary and was honking their horn, all of those circles would be perfectly concentric, uniformly distributing out from a center, like the rays of the sun. But because it is moving towards the person, so you need to understand that if you consider that a sound source has a frequency of, let's say, 1 hertz. Think about it. It means in 1 second it produces how many vibrations? 1. Means it produces 1 compressions and 1 reflections within a duration of how much second? 1 second. Let us consider that the speed of sound is, let's say, 350 meter per second. এই নাম্বারগুলো একটু মনে রাখেন। ওকে, স্পিড অফ সাউন্ড হচ্ছে 350 মিটার পার সেকেন্ড। মানে হচ্ছে সোর্স যদি সেন্টারে বসে থেকে নড়াচড়া না করে সাউন্ড প্রডিউস করতে থাকে, একটা সাউন্ড প্রডিউস হবে, তার 350 মিটার দূরে আরেকটা কম্প্রেশন প্রডিউস হবে, তার 350 মিটার দূরে আরেকটা কম্প্রেশন প্রডিউস হবে। সো কন্টিনিউয়াসলি এগুলো কি হবে? 350 মিটার দূরে 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 ওয়েভলেন্থ নিয়ে আস্তে আস্তে ছড়াই যেতে থাকবে। রাইট? Where did the 350 meter come from? B equals to F lambda. Right? Now, interesting part is that if we now add a 50 meter per second speed, think about it. If we now add a 50 meter per second speed to the sound source towards the observer, let's say the source is moving and the speed of the sound source is 50 meters per second towards the observer. What will happen? When the first sound source is created, that produces a uniform circle of 350 meter radius. By the time the source produces a second, it is not in the same position of the original sound wave. It has moved forward by how much? 50 meters. Then it will produce a second sound wave. It means the circles are not going to be concentric anymore. They're going to be compressed to the left. And on the left side, the waves are going to be 300 meters apart from each other. Because from the original point, the sound has covered 350 meters, and the source has already covered how much? 50 meters. Then it produces the second sound. So overall, the gap between the distance between the first compression and the second compression will no longer be 350 meters. It is going to be somewhat less. So waves are getting squashed up. And on the rear side, the total distance will be 400 meters. Right? Now think about it. Whenever we consider for a single medium, let's say sound, the frequency is, the speed of sound in air is practically constant. Speed of sound in air is practically very constant, which means for the source, for the person, for everyone, speed of sound is a constant. This person is experiencing 300 meter worth of wavelength with a speed of how much? 350 meter per second. So what will be their observed wavelength? What will be their observed frequency? That's gonna be 350 divided by 300. It's gonna be more than 1. Whatever that becomes. This is for the observer who is in front. What will be the frequency if there was an observer standing over here? The observer who are together here will be observing 350 divided by 400. So that wavelength is supposed to be more than 350, so the frequency is supposed to be less than 1. Source কিন্তু per second একটা করে wave produce করতেছে. The true frequency of the source is how much? 1 hertz. But due to the relative velocity between the source and the observer, the observed frequency is not 1 hertz anymore. The observed frequency is somewhat more or less depending on where you are standing. এই ঘটনাটাকে আমরা বলছি ডপলার এফেক্ট। বুঝা যাচ্ছে? সো এটা একটা ম্যাথমেটিক্যাল ইকুয়েশন আছে, সেই ম্যাথমেটিক্যাল ইকুয়েশন আমি পরে তোমাদের দেখাবো। তো এই অ্যানিমেশনটা এতটুকু দেখলে হবে। এরপর এখানে আমরা ফর্মুলা আছে, ফর্মুলাটা তোমাদেরকে ডিফারেন্ট ফর্মুলা দেখানো আগে তোমাদেরকে ডিফারেন্ট একটা ভিডিও দেখায়। The same thing is equally applicable for light as well. The same behavior is equally applicable for light. Have a look.
To make that clear,
The Doppler effect. In Sheldon's words,
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
the Doppler effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wavefronts bunch up, and behind it, they're spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a height.
See what they mean? Shorter wavelength on the forward side and farther wavelengths on the rear side. Yes.
Also, the observer of the station in the front edge will get the sound or the faster than the person who's in the back.
Precisely.
Frequency. And if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect, the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes
The most important word of this entire definition is what? Apparent. You cannot write change in frequency, because if you write change in frequency, it would imply that the source itself is giving us different frequency. Source itself is not giving us different frequency. What we are seeing is different from what the source is giving. No, we use this term and we stick to the definition. বুঝার জন্য আমরা different term use করতে পারবো.
sense, but it gets interesting when you consider some of its applications. So let's say you are standing in the middle of the road. That's you, and a car drives past you very fast. As it does so, it honks its horn because you're standing in the middle of the road. The horn to you might sound something like this. So it starts at a high pitch and moves to a lower pitch, even though from the driver's perspective, the horn is playing the same pitch the entire time. So what's going on? As the vehicle's coming towards you, the sound waves that it's emitting bunch up, and so are delivered to you at a frequency, which you interpret as a higher pitch, because the frequency of sound waves is pitch. And then when the vehicle passes you and is moving away from you, the sound waves spread out, and so you hear them at a lower frequency, a lower pitch. So that's how the Doppler effect works with sound. It also affects another kind of wave, light. So let's say you look at your observatory and you see a star. Just like the car's sound waves, if the star is moving towards you even just a little bit, the light waves that it emits will be bunched up, meaning that you see the light at a higher frequency than it actually is. Frequency in sound is pitch, so what does it mean for light? Well, if we look at our handy pocket electromagnetic spectrum chart, we'll see that a small change in frequency, the visible light, will change its color. Higher frequency light waves mean bluer light, and lower frequency light waves mean redder light. This is called redshift, and it may possibly be among the weirdest and coolest things of all time. Stars, or anything that you can see, change color depending on their relative motion to you.
Did you see what happened? What happened? তোদের যাওয়ার সময় কালার কি ছিল? No. Exactly. তোদের তো যাওয়ার সময় ছিল green. Away from the observer সময় ছিল হচ্ছে orange বা red. Watch again. Eyes on the screen. Eyes on the screen. এই পার্টটা দেখেন.
Or anything that you can see, change color depending on their
Did you see that? See again.
stars, or anything that you can see, change color depending on their relative motion to you.
বুঝা
Of
যাচ্ছে?
course, you can't see this minute difference with your eyes, but astronomers with the right equipment can use this effect to tell whether stars are moving away from or towards.
Did you see the color change of the stars? Watch again. These are minute details which are amazing for this video. Star color গুলো এখন কি? Have a look.
With the right equipment can use this effect to tell whether stars are moving away from.
See what I mean? Which means if the sources are seen to be getting away from you, you will be also experiencing Doppler effect for light waves as well, because they are also waves. Getting away sources would appear to become more red than they truly is. Getting closer sources would appear to be more bluish compared to they truly are. Yes. You have to sit over there in the first row.
Or towards Earth. As it turns out, almost everything we can see in the universe is moving
Same
away
as your motion.
very quickly, which is both important.
চৈনের সাথে বসেন।
The Earth might get very lonely.
Okay, বসো। বইটা সরা রাখো ওদিকে, দুজন বসো এখানে। না না, ফার্স্ট বেঞ্চে বসো।
In this video,
So Doppler effect কি কনসেপ্টে বুঝা গেছে কিনা? I'm just going to drop some stuffs to summarize the whole thing. Just have a look. This is the source. This is the observer. For your syllabus, we are covering only a small portion of the whole thing. What is it that we are covering? we are covering when the source is moving with respect to the observer. Now, moving with respect to the observer necessarily means that they have a relative velocity between them. It doesn't mean that the source has to go through you. It doesn't mean the source has to go through you. For example, as long as the distance between the source and the observer is decreasing, that is called approach. Minimum distance. Increasing distance, that's called separation. Mone ache? Momentum chapter chilo, speed of approach, speed of separation, same drill. So whenever the two things are getting closer to each other, the observed frequency will be higher. Whenever the distance is increasing, the observed frequency will be lower. এখানে আমি দুইটা কি জিনিস তোমাদেরকে ইন্টারেস্টিংলি বুঝায় বলতেছি, একটু খেয়াল করেন। By the way, if both of these things are moving like this, there will be no observed Doppler effect. For example, whenever the for example, whenever the car driver honks the horn and keeps on driving, they experience the exact same frequency as the horn's true frequency. Whoever it is the pedestrian experiences the Doppler effect. Now, interestingly, Polwan, দেখেন, I don't want to draw two cars. Should I draw two cars? I could draw two cars. A minute. Let's say this is a pedestrian road, midline of the road. Honda. My point is, listen, if this source is getting closer to the source and eventually moving like this person is going to experience a certain variation of the frequency. But what if this source is moving this way and this Honda is also moving this way? Then as they cross each other, they're going to experience a much bigger change because their relative velocity is going to be more with respect to each other. So the bigger the difference in their velocities, the bigger is the difference observed. এটা একটা ম্যাথমেটিক্যাল ফর্মুলা আছে, ওকে? ফর্মুলা দেখাবো, বাট ফর্মুলাকে একটা জিনিস বলি। What is truly important for you to understand is to distinguish between two terms. একটা হচ্ছে intensity বা volume, আরটা হচ্ছে frequency. Intensity and frequency are not the same thing. What do I mean? এই ফিগারটা বোঝা যাচ্ছে? What am I showing you? আমি দুটো গ্রাফ এঁকে দেখাচ্ছি, গ্রাফ দুটো খেয়াল করেন। I wrote D over here. What do you think the D represents? Distance of what? Nah. Distance covered by the source লিখি। Here is what I wanted to see. Have a look, Polaman. Doppler effect basic একটা idea হচ্ছে source is going to get closer to you and eventually the source is going to cross you and eventually leave away from you. What that necessarily entails, as long as the source gets closer to you, you're going to keep on hearing a louder volume. So which means intensity sounds to be like this. But if you want to understand the idea for Doppler effect, whenever the frequency gets close, if I want to draw the graph for frequency variation, distance covered by the source, this is the frequency observed. And this one, the horizontal ground, represents frequency of the source. Pulawan, দেখেন. For as long as the source is coming towards you, let me draw the dotted line. as long as the source is coming towards you, you're gonna keep on hearing a constant high frequency, assuming that the source has a constant speed. Drops down. বুঝা যাচ্ছে? নেগেটিভ না, এখানে কি লেভেল করছি? ফ্রিকোয়েন্সি অফ দ্য সোর্স ইটস নট জিরো। মনে করো ফ্রিকোয়েন্সি অফ দ্য সোর্স ছিল 1 হার্টজ, এটা তোমাদের এক্সাম্পলের জন্য বললাম। সো এটা হচ্ছে কত? 350/300, আর এটা হচ্ছে কত? 350/400. So there is not a zero axis, there is a y-axis intercept line where the true frequency of the source is shown. So frequency is going to have a sudden shift from a high value to a low value as it passes by the observer. Sudden is the key word here. Yes. No, the frequency is going to gradually increase if the speed is variable. What I'm considering in this case, for this example, হ্যাঁ আরে কথা বলা না করো। No, no. Oh. ওরা কথা শুনো, কথা বন্ধ। Listen, if the source is moving at a constant speed, this is the type of frequency variation that you're going to come across. What if the source was moving with varying speed? Now, if the source is accelerating, if the source is accelerating, then it's going to look like this. The faster the speed, bigger is the difference. But এইরকম এক্সাক্ট প্লটেবল গ্রাফ তোমাদেরকে দিবে না। তোমাদের সিলেবাসে একটা এই ধরনের কোশ্চেন আসছিল, যেটা তোমাদের সলভ করাবো। সেটা হচ্ছে এরকম, hear me now. There was an observer over here. Yes, sir. And there was a merry-go-round. Oh. And the kid is screaming. Okay. That was not the question. I'm setting up the question. The kid is screaming at a constant frequency and while riding the merry-go-round. Now, merry-go-round is a pretty slow ride, right? It takes time for one complete revolution. So what's going to happen? If you are at a certain distance, as long as the kid is coming towards you from the opposite end of the merry-go-round and reaching like this, and the merry-go-round is rotating like this. So when the kid is over here, coming towards you, you're going to observe increasing frequency. You're going to hear the highest frequency when the kid is over here. একে দেখাই বলবান, একে দেখাচ্ছি। তোমার তো কম্পোনেন্ট বুঝো, বুঝো? I experience this every night. সে তার মাকে দেখতে পারে না, আমার মেয়ে, এবং তারপর দেখতে না বলে it's a mess. থাকো বলবান হাসাস। কোশ্চেনে দেখেন, অ্যাকচুয়াল কোশ্চেনে তোমাদের পেপারও আছে, সলভ করার সময় তোমাদের করা লাগবে, কন্টেন্টটা বুঝো। এই দাঁড়াও, let's say the source is over here going in an anti-clockwise circle. I'm marking 4 different points over here: point A, point B, point C, and point D. What I want you to understand, here is the observer. Okay, this is the observer standing over here. at these two positions, the relative speed of the source is the highest with respect to the observer. এই পজিশনে going away স্পিডটা সবচেয়ে বেশি, এই পজিশনে অ্যাপ্রোচিং এর স্পিডটা সবচেয়ে কি বেশি, এই পজিশনে রিলেটিভ ভেলোসিটি ভ্যালু হচ্ছে 0, এটা কি বুঝো? কারণ পারপেন্ডিকুলার না। সো ইন দ্য অ্যালাইনমেন্ট অফ দ্য অবজারভার এটা কোনো কম্পোনেন্ট আছে নাই। ইফ ইউ আর কনসিডারিং, লেট মি ফিনিশ, তারপর কোশ্চেন নিচ্ছি। ইফ ইউ কনসিডার, সামনে এসে দাঁড়া করা দিব, 2 ঘন্টা লেকচার দিবা তোমাকে, আমি তোমার কথা শুনতেছি, তুমি আমার মতো লো ভলিউমে কথা বলো, সমস্যা নাই, পরে এখানে রাখেন, এখানে এই টেবিলেই রাখেন, এখানে রাখেন বাবা। If you consider the velocity of the source at this position diagonally like this, এদিকে জাজ করো, এই ভেলোসিটি একটা কম্পোনেন্ট হবে এদিকে, এই ভেলোসিটি একটা কম্পোনেন্ট হবে এদিকে। ডপলার ইফেক্ট কোন কম্পোনেন্টটার জন্য হবে? The horizontal one, because the vertical component is not causing you the distance change. For the Doppler effect to happen, you need to have distance change between what? Between the source and the observer. So velocity যে কম্পোনেন্টটার জন্য আমাদের distance change হচ্ছে with respect to time, that component causes the Doppler effect. So this component becomes biggest over here. This component becomes biggest over here, which means this is the location where the observer should experience the highest frequency of shout. This is a location where they should experience the lowest frequency. Here they will experience the original frequency. Here they will experience the original frequency. So what happens from here to here? Frequency gradually increases. What happens from here to here? Frequency gradually increases. What happens from here to here? Frequency gradually decreases to original. Here to here increases once again. Now, a minute. If you are trying to draw the sketch graph of this thing, the examiners does not penalize you if you draw a zigzag graph or a square graph. The most common thing, because this is a circular motion, is to draw a sinusoidal curve. So this graph, if I want to plot for the frequency observed with respect to time, and this is the frequency of the source, and here is A, here is B, here is C, and here is D. Now, where should I give which point? And here is D again. A পয়েন্টটা কোথায় দিব? A পয়েন্টটা হবে হচ্ছে লোয়েস্ট, রাইট? মনে করো এখানে দিলাম। B পয়েন্টটা হবে কোথায়? অরিজিনাল ফ্রিকোয়েন্সি। C পয়েন্টটা হবে কোথায়? হাইয়েস্ট। ডিটা হবে কোথায়? কারণ এটা অরিজিনাল থেকে শুরু হওয়ার কথা। So this graph is supposed to look like, has a shape somewhat like a sinusoidal curve. বলো, কোশ্চেন বলো। জানি, you had a question.
Sir, why is it BNB?
Oh, because at this point, exactly at this instantaneous point, the speed of the source has no component parallel to the direction of the alignment. So because for the Doppler effect to exist, you need to have the in-between distance changing over time. That's the whole idea of the word relative velocity. What does it mean that two persons have relative velocity in between them? It means their in-between distance is changing. Recall, if this is the source and here we have the observer, as long as the source is moving with respect to the observer, that gives you Doppler effect. That movement can happen over here as well. That movement can happen pretty close by as well. But as long as the distance is coming minimum, that's when the approach finishes. Exactly. If it would not be happening, if it was moving in a circular motion, if it was moving at a circular motion while keeping the distance equal, you don't have Doppler effect. You would get the exact frequency. It has to either get closer to you or it has to go further from you. Either of these two things have to happen, which means the velocity have to have some component along the line joining you and the source. If that's not the case, then you're going to get the exit true frequency of the source at that position. Yes. এক মিনিট, একজন করে বলো। অফিস থেকে আপনাকে ডেকে নিয়ে আসো বাবা, ব্যাগ থাকুক। হ্যাঁ, we are considering the angular spacing to be negligible. Consider the angular spacing negligible. Assume that for the sake of simplicity. But yes, what I understand what you mean. It should be the tangent of the circle. So এই অ্যাঙ্গেলটা একটু ছোট হওয়ার কথা, আউটার অ্যাঙ্গেলটা একটু বড় হওয়ার কথা। Yeah, I agree, but no. Yes.
The object was approaching from B, right, and the perpendicular. From the relative vector, the B, so imagine B standing there, I'm going to get down to the partition from right down.
Yeah, that happens. That's what gives us the sensation for where the object is located. Yes.
That's so, same thing goes towards me in another position.
Yes. That way you would understand that the object is either on the right of my head or on the left of my head. Yes, we would. Absolutely.
Doesn't that say give us other?
No, it doesn't. Because the total size of our head is usually always way too smaller than the typical wavelength of a sound. The size of our head is usually way too smaller compared to the size of one wavelength of a sound. Typically দুইটা মাথার গ্যাপ কতটুকু?
Typically,
50 কে 15,000 দিয়ে ডিভাইড করে দেওয়া তো কত হয়? If you consider the typical maximum frequency audible by a regular adult person, that frequency is about 15,000 hertz. The speed of sound in air is nearly 350 meters per second in RT. So if I divide that, I get the wavelength to be about 0.023 meters, which means one wavelength is about 20 centimeters.
Oh, that's the.
That's pretty much how it to head. So it is unlikely that you're gonna be able to detect the Doppler effect, because it's important to understand that if you are trying to detect the Doppler effect, the gradual change would not cause it. In this case, you're gonna hear a continuous change of the frequency. So this would be observable by you, then sense it. But if you want to totally measure it, you need require electronic equipment like a microphone connected to a CRO and everything. That's gonna be necessary. Idea বুঝে গেছে? Take away. Apparent wordটা লেখা মিস করা যাবে না। Number 1. 2 number, important factor হচ্ছে relative velocity. Distance has to change over time. 3 number, intensity means volume will be gradually increasing as the source gets closer, and volume of sound. মানে typical physical volume. Sound volume. ঠিক আছে?
Intensity.
Yes. Intensity is gonna be increasing gradually as the source gets closer. Intensity will also decreasing as the source gets further away. That's not Doppler effect. Doppler effect is the sudden change of frequency as the object goes past the observer. As the source goes past the observer. এটা একটা ফর্মুলা আছে, ফর্মুলাটা দেখেন। The formula looks like this. ফর্মুলাটা লিখো সবাই। পড়ে দিচ্ছি f observed equals to bracket division line speed of wave divided by speed of wave plus or minus speed of source that flows into frequency of the source. Abu আসছে বলছে? আবুকে পাইছো? অফিসে কাউকে পাইছো? কে? বলছো? অফিসে কিছু নাই, অফিসে কিছু নাই, সব তোমাকে দেবো, দিতে হবে। কি আছে? এই ফর্মুলা বুঝছো? বলো খেয়াল করো। Eyes on me. This formula is not giving you the change of frequency. This formula is really giving you the observed frequency. You have to keep careful for that. Question লিখেন। I am really sorry. Going to class are rules. I didn't know. Well, this is one of the. Yes. No, absolutely. তারা শোনাতে পারে অফিসে জিজ্ঞেস করো শেষ হয়ে গেছে What am I asking to find out? How did you do it? I don't know how you did. Nah. Well, hold on, here's the catch. You don't understand. You didn't give pass pass again.
Yeah, yeah.
What do you mean this pass pass has serious
Approach our separation.
এক কত সময় করতে হবে
Minus.
Wrong.
Minus.
ঠিক এক কত সময় আলটিমেটলি এই ফ্রিকোয়েন্সিটা বড় হওয়ার কথা তো এখানে ডিনোমিনেটর ছোট হতে হবে
Denominator putting.
আমি তো ক্যালকুলেশন করে দিয়েছিলাম নিশ্চিত করে দেখা আছে একটু কথা বলছি করে তারপর দেখবো so when the source is approaching the person then if you use minus and find out one frequency that's the frequency observed while the source getting closer when it's getting away then if you use the same formula but plus then you get two different values
What's your
and then you have to find out the difference of those two numbers
There is a 50.8.
what's your minus or the plus square? Because the 90 kilometer per hour to
how do you equal to power কি নিতে পারছেন নিছো কত আসছে
1. No, it should be
15 না 10
no, it should be like it's 80/9. So it's
how do you equal to power 80 by 9
that's what I understand.
I have the 36 days now 36 দিলে মনে হয় পাপেটি কত আসছে
Their question is 24.5.
oh sorry I'm 36 days 36 days আমি কি 36 বানাই দিব না কিলোমিটার পার আওয়ার মানে হচ্ছে 36 ইনটু ওদিকে দাও ওদের হাতে দাও তোমার হাত দাও বা পার নিচে একটু মেরে দেখো এতো When you want the observed frequency to be bigger than the source frequency, then the denominator has to be smaller. তখন মাইনাস হবে অ্যাপ্রোচিং এর জন্য মাইনাস হবে আর লিভিং এর জন্য ইয়েস না না এই দুটো বের করেন বের করে সাবট্রাক্ট করেন আমি এখানে রাউন্ড আপ না করে একবারে বসাইছি একবার ক্যালকুলেটর বসান বসায় দেখেন কত আসে বলো ওটা হচ্ছে যদি অবজার্ভার মুভ করে তোমাদের সিলেবাসে অবজার্ভার মুভমেন্টের কেসটা দেয় নাই তো both of them can move then you're going to have supersonic scenarios not Doppler effect তোর কোনো অবজার্ভ ফ্রিকোয়েন্সি নাই বিকজ সাউন্ড রিচ করার আগে সোর্স থেকে ক্রস করবে সো হি অর শি ইজ গোনা হিয়ার কাবুম as a source passes him by physically I don't know. I honestly don't. এটা ভালো কত আসছে? ফালতু ক্যালকুলেটর পাই না। কত বাবা? এই টাইপের কোশ্চেন এমসিকিউতে হর হামেশায় আসে। বিকজ অবজারভার তো শুরুতে অরিজিনালটা এক্সপিরিয়েন্স করবে না। সোর্স ইজ গেটিং ক্লোজার and then suddenly dropping the frequency and becoming a new one. So observer throughout the whole scenario কখনোই অরিজিনাল ফ্রিকোয়েন্সি এক্সপিরিয়েন্স করতেছে না। আমি look at the graph. Observer is experiencing this one as the approach is happening. And there is a sudden change like this and observer is getting a different one. Original source of frequency শুনছে না, শুনবে কখন? রেস্টে থাকলে অথবা if they are moving at the same speed in the same direction so that the relative velocity would be zero. That's not the case. Yes. Nah. Because the true value of frequency can never be negative. Change of anything can be positive or negative. Scalar quantity change or negative হয়. Negative work done. Frictional loss can be negative. But net energy of an object can never be negative. মামুন এখানকার কাজ শেষ। না বুলেট একটু পড়া দাও। হেডিং লেখো, হেডিং লেখো। আমি বলতেছি স্ট্যান্ডিং ওয়েভস ইন স্ট্যান্ডিং, আমাকে দাঁড়া লিখতেছি, হ্যান্ডরাইটিং এমনিতে খারাপ, আলাদা খারাপ হচ্ছে। স্ট্যান্ডিং ওয়েভস ইন স্ট্রিংস and pipes. Here is the thing that you need to understand. If we want to produce a standing wave within a string, you cannot produce all random different frequencies. There are some discrete stipulated values of frequency that you can generate. Discrete কথা মানে বুঝো? Continuous variable, discrete variable difference বুঝায়? Do you know this or not? Should I explain? I'll explain. For example, temperature. If an object's temperature increases from 10 degrees Celsius to 15 degrees Celsius, it had to pass through all possible numbers in between them. Name any value, it had to be there and pass through it. But if you think about the amount of money that you can physically own, not bank account, physically own, it has a fixed value. For example, in Bangladesh, the most common available, let's say, denomination of money, physical money, is 1 টাকা। ধরো 1 টাকার নিচে কোনো মানি বাংলাদেশে পাওয়া যায় না এখন। It means you cannot be fraction of a taka richer or poorer. Your total amount of wealth in taka will always be a full multiple of what? That's a discrete quantity. বুঝাচ্ছে কি? You can never buy 1.5 boroi. Can you? You can buy 1, 2, 1 kilogram, 12, but you cannot buy 1.5. Doesn't work. So number of fruit is a discrete variable. বুঝা যাচ্ছে কি ডিফারেন্স? কেন এই কথাটা বলতেছে খেয়াল করেন। Important part is that whenever you are trying to judge a certain fixed amount of medium, there are two properties that you need to see. Number one, throughout the entirety of your upcoming discussion, in one single medium, the speed of sound would remain same. V will be same. So if you have a one string that is tied up on two sides, no matter what frequency you vibrate it by, you're going to have the same speed of wave through the sound, through the wire, going forward and backward, forward and backward. If you have a higher frequency, your wavelengths will be smaller. If you have a lower frequency, your wavelengths will be bigger. That's the way it works. Same thing, if you have a flute, that's a windpipe. Flute is a what? Windpipe. You blow in from one end and there's another open end on the other side. So in that medium, your vibrating medium is a trapped amount of air. So the speed of sound in air for that confined medium is also a constant number. You cannot have different values. এই জিনিসটা হচ্ছে ফার্স্ট মনে রাখার জিনিস, স্পিড অফ সাউন্ড উইল অলওয়েজ বি কনস্ট্যান্ট, এক নাম্বার। দুই নম্বর জিনিস হচ্ছে, if you are trying to produce standing wave within a confined medium, you cannot choose to have random values of wavelength because there are some constraints to it. Have a look. আমাদের যদি একটা স্ট্রিংকে আমরা এখানে এই দুই মাথা কানেক্ট করি, let's say this is a string that is tied up, but it's a pretty flexible string. It's currently taut, but you can pluck it and it can have a little bit of play. It can be extended a little bit to give it a bit of curved shape. If you want to make a standing wave in this point, you have to understand these 2 points have to be node. This point also have to be what? Node. Because you have tied up these two ends. Stationary wave stationary point গুলোর নাম কি ছিল? Node. আর biggest amplitude point এর নামগুলোর নাম কি ছিল? Antinode. তার মানে ওয়্যারের জন্য দুইটা বর্ডার পয়েন্ট অবশ্যই কি হতে হবে? নোড হতে হবে। তার মানে আমি যদি এখানে সবচেয়ে বড় ওয়েভলেন্থ আটাই, তাহলে মাঝখানে একটা অ্যান্টিনোড হতে পারে। ইন দ্যাট কেস আই ক্যান শো ইট টু বি সামওয়াট লাইক দিস। দেখো এটা বোঝা যাচ্ছে কিনা? আমি তোমাদেরকে এটা আঁকতে হবে না, এটা বুঝো। I can set up a very specific frequency of wave which is going to give me this exact wavelength for the stipulated speed of the medium speed. ধরো medium speed যদি let's say 1000 meter per second হয়, because this is solid medium, let's assume, আর এই টোটাল লেন্থটা যদি let's say 2 মিটার হয়, তাহলে এই ফ্রিকোয়েন্সিটার ভ্যালু কত হবে বলেন?
500.
এক্স্যাক্টলি, একটা লুপ মানে হচ্ছে হাফ অফ দ্য ওয়েভলেন্থ। কি এটা কি মনে আছে তোমাদের? একটা লুপ যে হাফ অফ ওয়েভলেন্থ, মনে আছে? স্ট্যান্ডিং ওয়েভের টিপিক্যাল শেপ আমরা আঁকি কিভাবে? এইভাবে। You can draw any amount of length that you want, but I'm choosing to draw a continuous parallel, let's say like this, and I'm going to show the other portion in dotted lines. এটা dotted line কেন দেখাচ্ছি? Because the wave is going to be either at this extreme position or at this extreme position or anywhere in between. এই দুই পজিশনটা সাইমালটেনিয়াসলি থাকবে না, থাকবে সিঙ্গেল স্ট্রিং মিডিয়াম। ওই জন্য একটা বার সলিড কেস, একটা বার আমি ডটেড লাইন দেখাচ্ছি। সো এইখান থেকে এই পর্যন্ত একটা ফুল সাইকেল, এটুকু হচ্ছে ল্যাম্ডা। তাহলে এইটুকু কতটুকু বুঝো? একটা লুপ হচ্ছে কতটুকু? হাফ ল্যাম্ডা। সিমিলারলি অ্যান্টিনোড থেকে অ্যান্টিনোড এটুকু কত? half lambda. But if you consider this between one antinode and the consecutive node, এটু কত হবে? lambda 4. এই রেশিওগুলো খেয়াল করেন। এটুকু হচ্ছে lambda, এটুকু হচ্ছে lambda by 2, এটুকু lambda by 2, but এটুকু হচ্ছে lambda by 4. Okay, mark this. So এই সিনারিওতে আমাদের টোটাল 2 মিটার লেন্থের মধ্যে আছে lambda by 2, তাহলে lambda ভ্যালু কত হবে? 4. v equals to f lambda, f এর ভ্যালু হবে হচ্ছে 1000 divided by 4, কত আসে? লিখলাম, বুঝা যাচ্ছে কি? 1000 divided by 4 equals to 250 hertz. The next stationary wave that I can accommodate within this part for another stipulated frequency, if I can somehow accommodate 2 loops over here. কেন 2 লুপ হইতে হবে? কারণ দুই পাশে অবশ্যই কি লাগবে? আগে এইটুকু নিছিলাম। Now you have to increase the number of loops within the same medium. So তোমার সেই পারে এখানে যেতে হবে। মাঝামাঝি কোথাও নিতে পারবা? এন্ড কি লাগবে? That's the constraint, right? So the next scenario that you can do, I'm drawing it now with a different color. The figure is starting to get messy. So please pay attention. The next scenario you can have is this, where you can have one antinode over here, one node over here, one node over here, and one antinode over here. Loop কটা হইছে? দুইটা। So এই টোটাল লেন্থের মধ্যে এগুলো পড়ে। এই দুইটা ওয়েভের মধ্যে এই টোটাল স্ট্রিং এর মধ্যে এখন ওয়েভলেন্থ কত? What is the wavelength of this wave? No, you have 2 loops within the whole length. 2 loops means 1 lambda. So what is the wavelength? 2 meter. You have two loops. Two loops mean 1 lambda. So the total wavelength over is how much? 2 meter. So how much would be the frequency in this case? 500 hertz. আর এটা কত ছিল? এটা কত আসছে? Do you see a pattern? Exactly double. Remember this. The next thing you can accommodate within the same space is how much? From here to here. কটা loop? বুঝা যাচ্ছে? এই পুরো শেপটাকে যদি স্কুইজ করে এখানে আটাই তাহলে লুপ হবে কত? এই শেপটাকে যদি এনে এই জায়গাতে স্কুইজ করে এখানে আটাই এইটাকে আমাদের লুপ হবে কত? তিনটা। তার মানে 2 মিটার লেন্থে তখন ল্যাম্ডা থাকবে কয়টা? 1.5. Now you think lambda কত হবে? লিখো। লিখতে ইজি হবে। 1.5 lambda equals to 2 meter. The lambda equals to 2 divided by 1.5.
4 by 3. 1.3333.
So 4 by 3 meter লিখলাম। If that is my lambda value, what will be your frequency in this case? Now your frequency heard should be 1000 divided by 4 by 3. This gives you. Now you have a consistent pattern to this. কারণ তিনটা ভ্যালু দিয়ে প্যাটার্ন ডেভেলপ করা যায়। সবগুলো মাল্টিপল আসছে না? লোয়েস্ট ফ্রিকোয়েন্সি কত ছিল?
250.
তারপর
500.
can you get anything in between 250 and 500 with this string? That answer is a no. এই স্ট্রিং দিয়ে একটা সিঙ্গেল ফ্রিকোয়েন্সি বানানো যাবে সেটা 250 হার্টজ, সেকেন্ড ফ্রিকোয়েন্সি বানানো যাবে 500 হার্টজ, থার্ড ফ্রিকোয়েন্সি বানানো যাবে is gonna always pick up on those discrete values. It cannot pick, yeah, because it is stipulated by the logic that দুই এন্ডে অবশ্যই কি থাকতে হবে? Nodes থাকতে হবে. So you have to accommodate full number of loops. 1 loop, 2 loop, 3 loop, 4 loop. So what is the next frequency you should expect?
1000.
So you are having all the consecutive multiples of fundamental frequency. In this case, the lowest frequency is what we call the fundamental frequency. The 500 hertz is what we call the second harmonic. Second harmonic, right? For example, if I tell you in terms of gun, musical stuff, sa re ga ma pa dha ni sa. So it's supposed to, the first sa is supposed to have the half the frequency of the last sa. The last sa is supposed to have exactly the double frequency.
Yes.
English এর জন্য কি বলে? হাবিজাবি কিছু একটা বলে, যাও। বুঝা যাচ্ছে? So that whole thing is what is called one octave. Octave has something important and increasing stuff for music. এই স্ট্রাকচারটা বুঝা গেছে?
Yes, sir.
Now let's try to understand. আমার স্ট্রিং এর আলাপ এখানে শেষ। Now let's try to understand for the scenario for pipes. পাইপের ভাইব্রেটিং মিডিয়ামের নাম কি? পাইপের জন্য ভাইব্রেটিং মিডিয়ামের নাম কি? What vibrates inside a pipe? Air. There can be air and water both in the pipe, but what will hear vibrating is air. Air. Okay, I'm telling you, it's air. Pipe can be of two different variations. We can have both end open pipe. We can have one end closed pipe. By the way, one end closed pipe is also sometimes called one end open pipe. Because এক চোখ কানা মানে এক চোখ কানা, একটা কানা হইতে পারে। It's not a good example. Exactly. One end open pipe basically means what? What is happening to the other end? So one end open pipe basically means one end closed pipe. They both mean the same thing. But both end open pipe means both end open pipe. So these are the two different variations we can have. Now, here is a catch. Did you see that waves can be reflected off a free end? মনে আছে দেখাইছিলাম যে ফার্স্ট ক্লাসে পালস যাচ্ছিল and then free end থেকেও একই ডিরেকশনে হচ্ছে রিফ্লেক্ট হয়ে ব্যাক করছে। For those of you who do not remember this, let me just show you one more time because some of you are having question marks in your faces.
Sir, আপনার ওটার বেস্ট এক্সাম্পল ছিল গ্লাস হাফ ফুল এন্ড গ্লাস হাফ এম্পটি।
All right.
এক গ্লাস ইজ নট হাফ।
Truth is, the glass is never full. The half of the glass is full of air, half of the glass is full of water. Sorry.
The glasses are always full.
Exactly. Unless you have artificially made a vacuum on it.
But for water is sealed and
Eh?
Why do you have to do it?
then water evaporated to temperature and then would be technically full and wow.
Maaf kar, maaf kar.
এটা মজা নট
বুঝছো কি দেখাচ্ছি? What is it that I'm trying to show you? From an open end, we can also have reflection. So, যেখানে গিয়ে মনে করা হচ্ছে তুমি একটা certain পাইপের এক এন্ডে ফ্লু দিচ্ছ, একটা both end open tube এর এক পাশে ফ্লু দিচ্ছ, like pretty the way the fluid works. That end is supposed to be a node. Now, the blowing end is supposed to be node and node. Where you apply the blow, do you think the location where you apply the air pressure, that location is supposed to be the most large amplitude or least amplitude location? You are introducing the energy, so that location by default has to be the antinode. So fluid যে জায়গায় তুমি blowing করতেছো, that location is supposed to be the antinode. Point one. কিছু কিছু মিউজিক্যাল ইনস্ট্রুমেন্টে যখন ভ্যারিয়েশন আছে সেটা পরে রাখবো। And the end where it is open to the atmosphere, ওই পার্টটাও কি antinode. That part is working like this, like a loose end. So open end থেকেও কি হওয়া possible? Reflection হওয়া
possible.
এই জিনিসটাকে ভালো করে মাথায় রাখবে, because otherwise you will feel like স্যার এক পাশ থেকে আমি সাউন্ড দিচ্ছি, সাউন্ডটা এক পাশ দিয়ে বাইরে বাতাসে ভাসিয়ে চলে যাবে। রিফ্লেকশন করতে গিয়ে হইতেছে ওপেন এন্ড থেকেও কি হয়, রিফ্লেকশন হয়। টেক দিস ইন ইউর হেড। এটার এক্সাম্পল আমি জানি না, হয় এটুকু জানি। I honestly don't, মানে I'm not bluffing. Now, because both of these two ends are open to the atmosphere, logically এটাও হইতে হবে antinode position, এটাও কি হইতে হবে, এটা হচ্ছে আমাদের both end open tube এর জন্য কি প্রিকন্ডিশন। তার মানে এটার smallest possible shape কতটুকু হওয়া possible, I'm rubbing off this figure because this has become pretty messed up, so I'm going to draw it once again. I want all of you to look over here, eyes over here. এই তো, সো এই টিউবের মধ্যে মিনিমাম কতটুকু আড়াইতে পারবো, এতটুকু। এক পাশে অ্যান্টিনোড, এক পাশে কি অ্যান্টিনোড, মাঝখানে অবশ্যই কি থাকতে হবে। So if I want to draw this shape might look like, to begin with, like this. কথা ঠিক আছে কিনা? I want you to tell me, be very careful before you answer, have a good look, how much lambda is inside this pipe.
One number. It's between a crest and a trough, so it should be
No.
No, one. It's half.
Okay, I'll show you one more time, have a look.
It's half.
এইটুকু কত ল্যাম্ডা?
Now,
এইটুকু না, এইটুকু হাফ ল্যাম্ডা, এইটুকু 1 ল্যাম্ডা, এইটুকু হাফ ল্যাম্ডা, have a look. How much is this much? বুঝো? So এখানেও তুমি কি পাচ্ছ, হাফ ল্যাম্ডা পাইতেছো, একটা সার্টেন ফ্রিকোয়েন্সি পাবা। এর ইমিডিয়েট পরে কতটুকু অ্যামাউন্ট অ্যাকোমোডেট করা পসিবল, if you want to go for the next higher frequency, you have to accommodate from here to the next. So first thing এর জন্য এইটুকু বড় হয়ে এখানে বসবে, পরের জন্য এইটুকু বড় হয়ে বসবে। How would the figure look like? How would the figure look like? Let me show you the figures. এটা আঁকা কষ্ট, এজন্য আমি আঁকা স্কিপ করতেছি, but let me show you this from a animation, from a image.
পুরানো ফার্নিচার
কোন দেখো the primary setup you can do is this one, right? If you want to go for the next higher frequency, you have to accommodate this much. Now, how many wavelengths are here? এটুক lambda by 4 এটুকু কি মাঝখান এটা lambda by 4 এটুকু lambda by 4 এটুক কত মানে মোট মিলে কত হইছে so did you just double the number of lambda
Yes.
একই লেন্থের মধ্যে আগে ছিল lambda by 2 নতুন ওয়েভের জন্য এখানে lambda এখানে কত ফুল lambda চলে আসছে so did you just not increase the number of loops and লুপের নাম্বার যদি একই জায়গাতে বাড়াও তাহলে ওভারঅল lambda ছোট হয়ে গেছে না আগে lambda ছিল হচ্ছে একটা লুপের ডাবল লেন্থ এখন lambda হয়ে গেছে একটা লুপের সমান so if you have reduced the wavelength your frequency should increase this is going to give you the double the frequency the third scenario you can accommodate is how much এইখান থেকে এই পর্যন্ত কতটুকু lambda আছে এখানে listen এটা কাউন্ট করার সবচেয়ে সহজ বুদ্ধি তোমাদের শিখিয়ে দিচ্ছি you're going to always count how many loops are there and whatever that is left on the two sides you count them separately one loop two loop 2 lambda by 2 2 lambda by 2 lambda by 4 lambda by 4 another lambda by 2 3 lambda by 2 লুপটা কাউন্ট করলে তোমার জন্য সহজ হবে সব সময় alright so now we have 3 lambda by 2 over here so you have accommodated 3 times this many wavelengths over here so your frequency is simply going to become 3 times as much because you now squash the wavelength to 3 times as this scenario so you get the third harmony second overtone or third harmony বুঝাচ্ছি এগুলো হচ্ছে মিউজিক্যাল টার্ম I mean music people would go count like 0 1 2 us regular people will count 1 2 3 I was joking just sa re ga ma pa tha ni sa last sa hocche first overtone of the original sa and then if you go like sa re ga if you go far higher that's going to be the second overtone so people who do opera singer or let's say Mizan Bangladeshi Mizan ke chino
Yes, sir.
exactly there are some people who can go really high scale like and then, not like me all right people what you can see exactly but with discrete values important term এই সিনারিও থেকে আমরা কিন্তু কন্টিনিউয়াস ফ্রিকোয়েন্সি পাচ্ছি না কন্টিনিউয়াস ফ্রিকোয়েন্সি পাচ্ছি we're getting discrete frequency values I want you to understand one thing very clearly stringer behavior আর both and open tube behavior same দুটাতে আমরা কি পাইছি সবগুলো মাল্টিপল পাইছি ফান্ডামেন্টাল ফ্রিকোয়েন্সি সেকেন্ড হারমোনিক থার্ড হারমোনিক ফোর্থ হারমোনিক কন্টিনিউয়াস তুমি যত জোরে পাবা তত জোরে পাই যাবে এবং এটা খুব ইন্টারেস্টিং একটা এক্সাম্পল তোমাদেরকে দেখাই এটা আমি প্রত্যেক ক্লাসে একটু করে দেখানোর চেষ্টা করি পিপল ইন দ্য ফ্রন্ট ইউ আর ইন ট্রাবল This is not gonna work. I need something. Okay, yeah. You hear this sound?
Yes, sir.
This is the fundamental frequency. Now hear the first harmonic. Wait. That was the third harmonic. I am missing out on the second. Second এর জন্য একটা certain control air flow দেওয়া দরকার There's the first one and then আমি সেকেন্ড করতে পারছি না, but you get the point. Did you hear there was a significant change in frequency? না, I don't want to. এই পর্যন্ত বুঝা গেছেন? Now we are entering into dangerous territory. Everyone, pay attention. Yes. What happens to one enclosed tube, or in other words, one open tube, is weird. It's a bit weirder because the property of one open tube has to be something like this. Have a look. If you consider the shape for one open tube, by virtue, opening the থাকতে হবে কি node আর closing থাকতে হবে, sorry, opening থাকতে হবে antinode আর closing থাকতে হবে কি. So the first scenario that you can accommodate over here is this much, just quarter of your wavelength, lambda by 4. I'll draw it again. Well, this is the biggest amount. This is the smallest portion of a single stationary wave that you can have. মানে একটা নোড থেকে একটা অ্যান্টিনোড পর্যন্ত মিনিমাম কত ল্যাম্ডা থাকে? নো, এটা দেখাচ্ছি। এটুকু হচ্ছে ল্যাম্ডা বাই 2, এটুকু কত? তো এই যে আমি এইখানে যতটুকু শেপ দিতে হয়েছে এইটুকু, এটাকে আমি কি করছি টেনে ওখানে বসাইছি, বুঝাচ্ছে? দুটো এন্ডে ক্লোজ থাকলে তো তুমি এনার্জি ফিট করতে পারবে না, এনার্জি ফিট করার জন্য তো একটা ওপেন এন্ড লাগবে। অলরাইট, সো দ্যাট হ্যাপেন্স। নাও হিয়ার মি আউট, this is the first thing you can do. Now the logic over here is that we must have a node on the left and we must have a antinode on the right. It is the logic. The first thing you can do is this much. The immediate next thing is how much? Over here, তাই না? So you have to go for this much line. মাঝখানটাকে তুমি নিতে পারবা? পারবা না, কারণ আমাদের কনস্ট্যান্টটা কি? এক পাশে হচ্ছে নোড থাকতে হবে, এক পাশে কি থাকতে হবে? অ্যান্টিনোড থাকতে হবে। So whatever the lambda that you could accommodate for the first scenario, fundamental frequency, for the immediate next possible standing wave, you have to accommodate 3 times that wavelength. So you are reducing the wavelength value by 3 times as much, which means your frequency is gonna be 3 times as much. So তোমার fundamental frequency যদি 100 Hz হয়, তোমার next possible frequency হবে হচ্ছে 300 Hz. You're gonna miss out on the even multiple. You're gonna miss out on the even multiple. 200 Hz তুমি এটা থেকে বানাতে পারবা না, শুধু কি বানাতে পারবা? 100 Hz পারলে তারপর 300 Hz পারবা, তারপর কত পারবা? তারপরে তুমি এইটুকু অ্যাকোমোডেট করতে পারবা, you're gonna have 500 Hz. So exactly, one enclosed tube will never give you the even multiples. It's gonna always give you the odd multiples. বুঝাচ্ছে কেন? Because lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, that way. How does multiple different figure look like? দেখো, have a look, people. Which harmonic is this? Which harmonic is this? Take a good look. This is a both and open tube. This is a second harmonic. How do you know?
2 times also give.
I'll give you a simple answer. There are 2 loops inside. 1 loop, half loop, half loop, 2 loops. And then what is this harmonic? Okay. Now, this is the fundamental frequency for the one enclosed tube. This is the no. This is the third harmonic. Second harmonic is missing. Immediate part take second harmonic also. It's about the multiple number of frequency. 100 Hz, 300 Hz. So this is the third harmonic. Second harmonic is missing. হবে না, বুঝাচ্ছি কি বলছি? কারণ তুমি lambda by 4 অ্যাকোমোডেট করলে একটা স্টেশনে প্রডিউস করতে পারবা, 2 lambda by 4 or lambda by 2 দিয়ে করতে পারবা না, কারণ 2 lambda by 4 দুই পাশে কি থাকে? দুই পাশে নোট থাকে অথবা দুই পাশে অ্যান্টি নোট থাকে, দিস টু ডাজন্ট অ্যালাউ ইট। এইটুকু রিকোয়ারমেন্ট কি, এক পাশে নোট থাকতে হবে আর পাশে অ্যান্টি নোট থাকতে হবে। সো তার মানে কি, ল্যামডা বাই 4, 3 ল্যামডা বাই 4, 5 ল্যামডা বাই 4। So this is third harmonic, this is, বুঝা যাচ্ছে? মেক সেন্স সো ফার? এই টাইপের এক্সপেরিমেন্টের দুইটা পসিবল ডিজাইন হয়। একটা ডিজাইন হচ্ছে তুমি একটা ফিক্সড লেন্থ অফ টিউব নিবা, তার উপর একটা স্পিকার ধরবা, স্পিকারটাকে একটা ভ্যারিয়েবল এসি সাপ্লাই দিয়ে অপারেট করবা। কি দিয়ে? ভ্যারিয়েবল এসি সাপ্লাই। এই এসি সাপ্লাইয়ের ফ্রিকোয়েন্সি তুমি যত আস্তে আস্তে বাড়াবা, ফর ভেরি স্পেসিফিক ফ্রিকোয়েন্সি suddenly the sound is going to become really loud. বুঝছো সেটআপটা? বুঝছো কিরকম? দেখে দেখাই। সেটআপটা হচ্ছে এরকম, somewhat like this. Let's say that's called resonance. That's called resonance. বলতেছি। AC supply. Okay? You have a fixed amount of length over here. You're going to start this AC supply from, let's say, 0 hertz. And gradually তুমি আস্তে আস্তে কি করছো, frequency বাড়াচ্ছে, frequency বাড়াচ্ছে. The very first frequency where you immediately hear the loud sound. If you wonder why should I hear a loud sound, because the whole idea of being able to produce a proper stationary wave or standing wave would be such, এই পয়েন্টে একটা অ্যান্টিনোড জেনারেট হবে। অ্যান্টিনোডের অ্যাম্পলিটিউড কি? অনেক বেশি। Whenever you have a high amplitude produced at the open end, your overall sound generated would be pretty loud, way louder than the sound of the loudspeaker itself. Yes, it's going to be the highest. So the way it works, বলতেছি, মনে করো তুমি 0 hertz থেকে আস্তে আস্তে বাড়ানো শুরু করছো। Let's say whenever you reached around 80 hertz, the sound started to increase. By the time you reached to 90 hertz, the sound diminished, went to the dim once again. It means somewhere in between this range, there is the appropriate frequency for this one's perfect lambda by 4. So you have to do a little bit of trial and error. তোমরা অলওয়েজে অপটিক্যাল এক্সপেরিমেন্ট করার সময় লেন্সটাকে ব্যাক এন্ড ফোর্থ মুভ করে ফোকাস পয়েন্ট বের করছো না? সেম স্টাফ। We are not going to move the position of the speaker. We're going to keep the speaker in the same position by holding it by a stand and stuff. But we're going to gradually try this trial and error, and we're going to try to hear that at which frequency do we get the loudest sound. That one is going to give us how much? Fundamental frequency. All right, that's point number 1. Then we're going to start increasing it once again. But now, let's say, I'm মনে করো হচ্ছে আমরা এখানে ভ্যালুটা পাইছি, let's say 84 এ। Let's say আমরা 84 এ পাইছি। So logic should tell you that we should find the third harmonic somewhat around to triple of that, by logic. So তার মানে হচ্ছে তোমার বাকি পুরোটা গ্র্যাজুয়ালি শুনতে শুনতে বাড়ানো দরকার নাই, জাম্প টু অ্যারাউন্ড about 3 times। 84 3 times করলে কত হয়? 250. So then let's say we're going to jump to 250, and then we're going to start to fiddle around it back and forth and find out the next loudest sound. At that point, we should be able to find out the, আচ্ছা ওই থার্ড হারমোনিকটা আকার সিস্টেম কেমন একটু দেখাই, কারণ এগুলো পরীক্ষা আঁকতে আসে। খেয়াল করো, whenever you are trying to draw the third harmonic, this is what you do. This is your pipe that is given. তোমাকে বলছে হচ্ছে এখানে থার্ড হারমোনিক আঁকতে হবে। রিমেম্বার, থার্ড হারমোনিকের শেপটা হচ্ছে মাছের মতো। ঠিক আছে, হোল্ড আপ। ফিফথ হারমোনিকের শেপটা হচ্ছে বাইম মাছের মতো। Okay. Whatever rocks your world. I want you to understand one part. You're going to have 1 lambda for half of the loop on the top, on the open side, and full lambdas underneath. Lambda বলতেছি, loop. You're going to have half loop on the top and full loops underneath that. So এইটা আঁকার জন্য এটা হচ্ছে আমাদের থার্ড হারমোনিক। এটা আঁকার জন্য আমি এই পুরো লেন্থটাকে অ্যাপ্রক্সিমেটলি 3 ভাগে ভাগ করব। কেন 3 ভাগ? এই যে lambda by 4, এই যে lambda by 4, এই যে lambda by 4, বুঝছেন? So just by eye or by using your ruler, you're going to give 3 dots, one over here, one over here, one around here, and one around here. আমি 4টা ডট দিয়ে ফেলছি যদিও, not a problem. And then you gradually, with smooth curve, you join these points with care and sincerity. And you label A, N, A, N. Make sense? যদি আমাদের ফিফথ হারমোনিক আঁকতে হয়, তাহলে টোটাল লেন্থকে কয়টা ভাগে ভাগ করতে হবে? 5টা 7th harmonic রাখতে হলে so you just use your ruler, that's the best way, easiest way. Measure the total length, divide it by the necessary number, give dots accordingly. Clear so far? এটা হচ্ছে এক টাইপের এক্সপেরিমেন্টাল ডিজাইন। অল্টারনেটিভ এক্সপেরিমেন্টাল ডিজাইনটা কেমন হয় সেটা একটু দেখেন। We're gonna have the same frequency of sound, but we're gonna change the length of the tube. What do I mean? Beautiful figure. তোমাদেরকে বোর্ডে ট্রেনিং ফর্ম লাগে দেখাইছিলাম, দেখো নাকি এটা ওকে পিছনে শেলফের থেকে একটা ট্রেনিং ফর্ম নিয়ে আসুন, যে ইউ টাইপের একটা স্টিলের রড আছে না, সেকেন্ড শেপের একটা আছে, একটা নিয়ে আসুন। People, check this out. The way this mechanism works is that we are using a variable amount of air. Listen. No. R2 সরান। আচ্ছা আমি আসছি। আমি ছোটবেলায় মরিচা নিয়ে খুব টেনশনে ছিলাম, জানো কেন? You see, listen to me. তোমরা তো বাংলায় কি এটা পড়ছো? আচ্ছা বলতেছি, বাংলা ব্যাকরণের একটা পার্ট আছে, সেটা হচ্ছে I'm not gonna able to control the class now after this. চুপ থাকো, ক্লাস শেষের আগে বলবো। দেখো, this is a tuning fork. I can do this. শোনা গেছে? What happened? The whole board works as an amplifier. If I lifted up this thing, it should be even louder. So what happens that whenever this thing vibrates, these two ends mount it to that. These two ends move like this and this, backwards and inwards. Whenever this one goes outwards, this holding rod goes upwards because they pull them up. And when they come inward, this is pushed down. So as the way this one vibrates at a specific frequency region over here, this is between 638 hertz, is that this one also vibrates at the exact same frequency. So if I hold it over here, the entire board material also vibrates at the same frequency. This one works as an amplifier. This is the same thing that is done using the hole in English. Acoustic guitar একটা কাঠের বানানো একটা বক্স থাকে না, তার উপরে তারগুলো লাগানো থাকে। If you do not have that box, yeah, it amplifies the sound, the same mechanism.
Sir, how does it work as an?
The specific structure that you have, না একটু ওখানে যা দেখো তো ওদের কি সমস্যা, সলভ করতে না পারলে ওদেরকে বাইর করে দাও। Again, the specific shape that this object has allows for some very specific type of reflections within the whole box, and altogether those sounds ultimately at the opening of the circle produces a huge resonance. So defined length of the path gives you constitutive interference at the opening. So overall, your wire and the air altogether produce a very loud sound, and that makes the whole sound loud, come out very loud. Simultaneously, all the entire body of the whole thing, that also emits sound laterally as well. So if someone is playing guitar at the center of it, at the center, and everyone is surrounding them, everyone can hear pretty loud because the sound comes out in all directions. But if you want to pick it up using a microphone, it's always best if you put it just in front of the hole. That is where the antenna is the most strongest. Now, people listen. The second experiment design can work something like this. We have a metal tube over here. It can be made of with plastic as well. It just has to be a hollow tube. Over here, we have a transparent water medium or a regular water medium. It has to be transparent. It has to be transparent water medium. And it's filled up with a certain amount of water. This is the bigger, wider tube. This is the thinner tube. If we change the amount that this metal tube is immersed in the water, we can effectively change the length of air column that is inside the metal tube. এটা যদি এখানে নামাই তাহলে আমাদের এয়ার কলামের সাইজ কি হবে? কমবে। এই যদি একটু বাড়াই, the way this experiment works is by a lot of trial and error. You have to hit the tuning fork, hold it on top of this metal tube, and gradually increase the length of the air column from a very minimum to a much bit higher. So initially you have to start this metal tube pretty much close to the water surface, so that your air column is the smallest. Air column is the smallest. Air column is the smallest. Yes, initially you keep it pretty submerged. Then you bang it, hold it on top of the metal tube, make sure it doesn't touch, because if it touches, then the vibration stops. And then gradually lift it up. As you're going to keep lifting up, there will come a height for which the sound will suddenly become loud. That is supposed to be a lambda by 4. First harmonic. And then you try it multiple times around that part, pitch it around, back and forth, adjust properly to figure out the perfect, best, loudest sound. And you mark the distance as L1. Why am I saying it to be L1? Why not lambda by 4 directly? Because there's a reason. Hear me out. Then we are going to keep on doing this, and at around 3 times the air column height, we're going to find out another harmonic. There's going to be a third harmonic. What? There's going to be a third harmonic. We're going to record that distance as L2. L1 and L2 are not exactly lambda by 4 and 3 lambda by 4. Why? Because of what we call enthalpy. Let me show you. Hold on. Once again, this case is not going to scale, but I want you to understand this. Everyone, have a look. It's important for you to understand, to produce the resonance, you have to hold the tuning fork on top of the tube. You cannot make it inside the tube, because if you put the tuning fork inside the tube, you're going to hit the metal rod side and your vibration will stop. Experiment is not going to be working. So for the baseline working of the experiment, you have to hold the tuning fork where? Slightly above. And the center of the tuning fork is the antenna. Center of the tuning fork is a jagah, so this point is your antenna, or in other words, this is your antenna. So these two positions are not perfect. Here is what I want you to understand. This is supposed to be placed over here, and the center of the tuning fork is supposed to be the center of your antenna. আমরা physically length measure করতেছি হচ্ছে L1. Actual lambda by 4 মধ্যে এক্সট্রা একটা আছে না? Because actual tuning forkটা হচ্ছে ধরতে হচ্ছে এই জায়গায়। তুমি চাইলে এটাকে একদম টিউবের মাঝখানে ধরতে পারবা না, because that way the vibration is not going to work. which means you are always holding your tuning fork slightly outside the tube. The total lambda by 4 that is starting to happen from the center of your tuning fork is longer than what you measure to be L1. So L1 is not truly lambda by 4. How much is lambda by 4? Have a look at the figure. L1 plus E is your lambda by 4. Now you do not know how much the exact E is. What you will do, you'll be careful to always hold your tuning fork at the same position on your tube throughout your experiment. If you're doing that both the readings, you'll do it. If someone else is doing it, they should do it. So both of these two persons, whenever one of them is doing the experiment, they're going to do the same amount of error for both the readings. So you find out L1 first, then you find out L2 next one. এখানেও L2 আর E কে add করলে কত হবে? 3 lambda by 4. L2 is the physical length of the metal tube that is from the open end. এখান থেকে water level পর্যন্ত হচ্ছে L. First resonance level এর জন্য L1, then 3 times as much nearly third harmonic এর জন্য হচ্ছে L2. লিখে দেওয়া আছে, ইকুয়েশন লিখে দেওয়া আছে, ইকুয়েশন লিখলে বুঝবা। খেয়াল করো। So I can write like this. L1 equals to, sorry, L1 plus E equals to B. Lambda by 4. L2 plus E equals to B. To the subtraction, you can write like this. L2 minus L1 equals to lambda by 2. This is a perfect equation. So we do not know exactly how much error do we did, but we did the error twice, and then if we subtract, we can get rid of the unknown error. See what I mean?
Yes.
And if we are trying to find out that true speed of sound in air by the resonance tube mechanism, we always have to take at least how many readings? At least 2 readings. Because one single reading will always have the end error into it. না, মানে এক্সপেরিমেন্টের ইনার ওয়ার্কিং গুলো বুঝতে হবে। এই বন্ধু বুঝা গেছে? The other type of question that you're going to come across, let me finish, তারপর তোমাদের বুকলেট দিব, সময় নাই, 9 মিনিট আছে, চুপ থাকো। এই দেখেন এসিমিয়ার ফিগার দেখে বোঝা যায়। This is a one and close to this end is close, and this thing of the loudspeaker over here. And initially, the entire bottle had an uniform layer of dust particles. You can use talcum powder, you can use dry sand, but you cannot use anything that is sticky. Okay. Then we set up the sound wave over here and gradually adjusted the frequency so that we ultimately get fixed locations where the sands or the talcum powders are seem to be heaped up. Heaped up হওয়ার মানে হচ্ছে এই জায়গাতে তাদেরকে কেউ ডিস্টার্ব করতেছে না। এই জায়গাতে এয়ার পার্টিকুলার ভাইব্রেশন ভ্যালু কত? 0। সো এক্স্যাক্টলি এই লাইন বরাবর কি হবে? নোল। এই জায়গা বরাবর কি হবে? এই দুটো মাঝখানে কি হবে? এইটুক লেন্থ ল্যাম্ডা টার্মসে কত? এইটুক লেন্থ ল্যাম্ডা টার্মসে ল্যাম্ডা বাই 2। আর এইটুক লেন্থ ল্যাম্ডা টার্মসে কত? বুঝছো? কোশ্চেন ফিগার দেওয়া থাকবে, গুণে গুণে ল্যাম্ডা টার্মসে হিসাব করে ভাগ করে ল্যাম্ডা বের করবা, বাকি ম্যাথ অটোমেটিক্যালি কাজ করবে। মেক সেন্স? আপনাদেরকে ওয়েবসাইট পেপার 1 পেপার 2 বুকলেট দিয়ে দেওয়া হচ্ছে। সবাই অ্যাটেন্ডেন্স দিছো? অ্যাটেন্ডেন্স দাও নাকি? আমার অ্যাটেন্ডেন্স আর হেড কাউন্ট করা হয়েছে? দাও, বুকলেট দিয়ে দাও। সবাই বুকলেটে আগে নাম লিখেন, তারপর হাঁটা বিদা করেন। Okay. I'll stop the recording first.
Okay.